Hi guys, I'm me again. So this is my exposición para la competencia número 5 de la materia de termodinámica. La competencia se llama Non-Reactive Mixtures. Me llamo Brian Irving Quiroz Ramírez. Mi profesor es Oscar Zárate San Pedro y estoy en la carrera de Ingeniería Electromecánica. Estoy actualmente estudiando en el Instituto Tecnológico Superior de San Martín Texmelucan. Voy en tercer semestre y pues vamos a dar inicio a la exposición. So the introduction is gas and vapor mixtures are fundamental in understanding thermodynamics, particularly in processes involving air condition, combustion, and atmospheric science. This study explored non-reactive mixtures, focusing on their composition, mole and mass fractions, behavior under pressure, volume and temperature (PVT) conditions are and the distinction between ideal and real gases. It also examines the interplay between gases and vapors, emphasizing properties like humidity, dew point, and enthalpy, which are critical for practical applications such as HVAC systems and meteorology. The mole and mass fractions are the mass fraction is the ratio of the mass of a component to the total mass of mixture, and the mole fraction is the ratio of the moles of a component to the total moles of the mixture. The sum of mass or mole fraction is a mixture equals. These concepts helps to describe the composition of mixtures and are used to calculate properties like average molar mass and gas constant for the mixture. So this is, for example, like a picture. The PVT behavior of gas mixtures. We have two choices: Dalton's law or Amagat's laws. Dalton's law says the total pressure of a mixture equals the sum of the partial pressures of individual gases, and the Amagat's law says the total volume equals to the sum of volumes individual gases will occupy and the mixture's temperature at the pressure. So we have looked at the law of Dalton and the law of Amagat. The properties of an ideal and real gas mixtures is that for real mixtures, properties like enthalpy and entropy depend only on temperature and real independent of pressure or the presences of their other gases. Real gas mixture require adjustment using compressibility factors or pseudo-critical properties for a better accuracy. So this is example. The mixture of gases and vapors is a mixture such as air, water, vapor like are treated similar to gas mixtures, but vapor pressure is critical in determining properties. These mixtures play a role in applications like the air condition. That is an example. Dry air and atmospheric air. Dry air is a mixture of gases, mainly nitrogen and oxygen, with no water vapor. The atmospheric air includes wet water vapor and properties vary with the humidity and temperature. So in this example we can see the components of the air. We can see the nitrogen, oxygen, other gases, argon, and carbon dioxide. The specific and relative humidity. The specific humidity is the mass of the water vapor per unit mass of dry air, and the relative humidity is the ratio of the current amount of water vapor to the maximum it can hold in a given pressure, expressed as a percentage. So this is an example. PV sat air is equal like P G equal P sat breeze, and the W sat air is equal a 0.622 PG divided P minus PG. The dew point temperature is the temperature at which air becomes saturated and water vapor condenses. This is a critical parameter for understanding humidity and precipitation. The dry bulb and wet bulb temperatures The dry bulb temperature is the regular air temperature measured with a thermometer, and the wet bulb temperature measured with a thermometer converted by a water-soaked cloth. It reflects the cooling effect of the evaporation, and it used to determine relative humidity. And for last, explain that's the specific enthalpy and volume of air-water vapor mixtures. These properties account for the energy content and space occupied by the mixture. Are used in thermodynamic analysis of HVAC systems and weather modeling. And this is a picture. So thank you guys for your attention. For more questions, text me.